Welcome to a talk about threat modeling. I'm glad to see you here, wanting to hear about this. My single goal here is to teach you the know-how and the mindset of threat modeling so that you can apply it to your systems, or at the very least, be competent enough to be able to do the basics so that if you work with a security expert, they can do advanced stuff for you so that your cooperation is more effective. This presentation should be relatively brief, so there should be enough time for questions and also queuing up being first for lunch. My name is Grzegorz Milka. I'm a tech lead at Google's Account Compromise Protection. Basically, we protect Google users from getting hacked. If you would like to connect, here are some things to break the ice. So my hobbies are learning all the crazy things about functional programming and using advancements there in my pet projects. Also spend ungodly amount of time configuring new of them. I'm generally passionate about software engineering and using it to make our lives better. So this story starts in 2022 when Russia started the full-scale invasion. I wanted to do more than just send money. I also wanted to use my skills for a good cause. That's how I and a team of volunteers joined International Rescue Committee, which is a major NGO helping people displaced by war, persecution, and natural disaster. Specifically, we joined Signpost, which is their information service that aims to provide empowering information. On this map, you see various services and countries they are engaged in. One curious fact about them is that they are very particular about the word empowering. It turns out that money in this space can come with strings attached. For example, a national government may want to give you funds, but under the condition that you do not tell the people how to settle in the country. Basically, you can help them survive, but you should help them move on as soon as possible. I would say that this kind of money wants to solve a problem, but not necessarily help the people. Anyway, one of our first tasks was to help with the Ukraine-specific instance of Signpost called United for Ukraine. Given that the Russian aggression has a sizable cyber component, one of the first questions we wanted to tackle is whether we are secure. It wasn't that we thought we were particularly important. We absolutely were not. But this project would be important to us, it would be important to our visitors, and there's nothing more motivating to a burglar than an open window. And this brings us to the topic of this talk, threat modeling, which is a technique that helps you answer a question like this, whether your system is secure. Threat modeling is essentially a structured approach to thinking about threats. It consists of 3 basic steps. First, you understand your app better by decomposing it into subsystems. Then use this decomposition to figure out what threats are facing, what threats your system is facing, and then you try to think about what you want to do about this, what are the mitigations that you want to enact. So let's do a mock threat modeling for United for Ukraine. Firstly, what is United for Ukraine? So United for Ukraine is a straightforward, static, multi-page app. Currently, its main functionality are per-country articles from topics such as how to cross the border to what's the status of your pets if you want to bring any. At the time in 2022, another one of its major functionalities was were chat and help request forms, where a visitor who needed help finding temporary accommodation or legal advice could provide their personal details, get connected with a coordinator who would help them connect to an appropriate provider. To decompose United for Ukraine, we'll use a data flow diagram. Generally, in threat modeling, use data flow diagrams. It shows you the architecture of the app. It shows you how the data flows through it, which is basically what you need to understand the security properties of your app. Naturally, United for Ukraine comes with a GitHub repo with its website code. We use a private GitHub repo to which software engineers had basically full access. United for Ukraine used Vercel to host, to build and host the files. Vercel had read access to the GitHub repo. Then Vercel was was serving those files to users' browsers, like a bundle of HTML, CSS, and JS files. Then there's naturally a database with the articles. Signpost use Zendesk, a customer management service, as a platform for this. So the Vercel node was able to read the articles in order to build them into static pages. And we use Zendesk UI, to which Content Manager had access to manage those articles. Lastly, there's a help request database, also hosted on Zendesk, which stored the tickets with corresponding to the request for coordination. Nominally, the tickets were expected to come from the unitedforukraine.org, but it's basically an open web endpoint. Then these tickets were accessible to coordinators who could then process them one by one. Threat modeling adds a unique touch to data flow diagrams in that it asks you to draw trust boundaries. So whenever you have two systems with different level of trust, basically when one system doesn't have full permissions to the other, there you have a trust boundary. Here I have used different colors to signify different trust areas. Basically, per platform, you have a different trust boundary. Okay. Okay. So armed with a decomposed app, the next step that you will want to do is to figure out per subsystem what threats this subsystem faces. The reason why you want to do this like this is there's a lot of threats. So to make this tractable, you want to divide and conquer as much as practical. To make this even more organized, there's a bunch of frameworks for threat modeling. Here I'm going to present one of the oldest and simplest ones called STRIDE. STRIDE is an acronym for the basic threat categories that you will want to consider. So S stands for spoofing, which is whenever you use false data to misidentify yourself. Think about SMS with scam SMS coming from post. There you see an example of spoofing vulnerability in action. There's tampering, modifying data or code, repudiation, when you can claim not to have performed an action. This is important because often for security, you want systems to be auditable. So being able to hide your tracks is a vulnerability. There's information disclosure, basically leaks of data. There's denial of service, making service unavailable or just degrading it. And there's also escalation of privilege whenever you gain a capability without proper authorization. So things like using Stack Overflows to then execute a shellcode to gain access, full access to your full permissions of your program, or SQL injection. Being able to craft a string that drops a database is an example of an escalation of privilege. So now what you will want to do is go subsystem by subsystem and threat category by threat category. You'll want to go in these pairs and try to find threats facing relevant to this pair. So for example, here I'm going to take a denial of service and a help request database. All right? And here's how I like to think about these things. So when I think about the database and denial of service, there are two ways. There are two failure modes that can happen to it. Either data is not there, and that's why it can't serve it, or for some reason, data is there, but the database management system is inoperational. So the way a database can be deleted is, well, someone deletes it, and the threat that can make it happen is, well, an employee account gets compromised, and this can be further exacerbated by having bad practices of having overly wide access to such permissions. On the other side, data deletion can happen because Zendesk, the platform we are hosted on, itself is breached. The way a database can be inoperational is, for example, when we are flooded with requests, so we can't handle it. So a threat could be that we miss the attacker uses automation and we don't have the anti-automation checks. Another way this could happen is there's a bug in the code which causes query, which make the system have a query of def, and the attacker abuses it without even automation to bring the service down. This naturally is not an exhaustive list. There's many more to generate from this, but it exemplifies how you want to reason about this. When you think about the threats, you generally want to write them down. It will categorize by the subsystem and the threat category, using a doc or more commonly a spreadsheet. So after you have generated the threats, you will want to pair them with mitigations. So here I've written some basic mitigations for the identified threats. The first one is not really a threat, it's more like a failure mode, but I think it's worth pointing out that generally, I don't know how data has been deleted, but if it has been deleted, in most threat scenarios, it's a good idea to have backups and to have restoration practices in place, right, and tested. If Zendesk has been breached, a good idea is to keep backups outside of Zendesk. If to mitigate an account compromise, well, we can enforce two-factor authentication, and to minimize the damage, we can make sure that we enact practices to minimize access to our assets. And lastly, to fix the threat of anti-automation, we can just add some kind of anti-automation mechanism like CAPTCHA. Now, a very important thing about threat modeling is prioritization. Not every threat is important, not every mitigation is worth it. Consider, for example, the Zendesk breach. You may, as we did, conclude that it's very unlikely to happen, and you may also decide, okay, we are not going to work on this. Another thing I'd like to point your attention to is the anti-automation checks. Here's the thinking is a bit different. So flooding a system with requests, that's easy. But the likelihood that anyone will bother is still low. And if that happens, this situation is recoverable. The site may be down, but perhaps site being down temporarily is an acceptable trade-off for not paying the cost of adding additional things to our system right now. Right? So believe it or not, this is it. This is the threat modeling process. So now whenever a security expert comes and asks you the dreaded question of what's your threat model, you can mollify them with these three things. You can explain to them, okay, this is how we understand our app working. This is what we identify as threats, and this is what we think about them, and this is what we are going to do about them. Right? Bonus points, if you actually have it written down, the gold standard is to treat it as you would treat architecture documentation. Right? In fact, threat modeling already has as its first step writing down the architecture. Okay. So before I set you out on your burgeoning threat modeling career, I have a few meta tips to make your threat modeling more effective. So it's a useful thought pattern to work your way from assets down, like I did with the help request database. So you think, okay, these are my assets, these are my endpoints, even features. These are the possible failure modes that can happen. And then you work yourself way to, okay, these are the specific threats that can cause this, and even go even deeper and create something called kill chains of threats that would need to happen in order for a specific asset to be breached. The reason why this is a useful thought pattern is that in threat modeling, you really want to be comprehensive. A particular pattern I see from novices is threat myopia, where they overly focus on specific threat category. For example, they try to get fancy and try to get out of the, be really out of the box thinking, and they miss sometimes like very basic threat scenarios. And as you know, adversary only needs to find one weakness. So the best remedy for this is to use threat modeling to really well understand your entire attack surface. I've talked about prioritizing threats and mitigations. but you can also prioritize the threat modeling process itself. Consider this. For this project with Signpost, we only have half a year, and United for Ukraine was a small part of it. We had barely a day to really do this. Also, the Signpost engineering team was small, and I would say relatively junior. It was like if I were to leave them with a stack of papers on threat modeling, I could have just as well threw it away. Right? So what I did is I did as much threat modeling as necessary. I did a basic sketch of architecture and concluded that what we most fear is in the Zendesk corner, right? Losing articles would be a disaster because that represents months of research by multiple people. Similarly, leaking data from the help request forms means leaking private data from vulnerable people, right? This would be probably lose trust to our platform. So that's why most of our thinking went into that corner. On the other hand, the web stack, it can crash and burn. Like literally, we don't care, right? What they can do, deface it. So it was mostly ignored. All right? And I think overall, we got a pretty good bang for our buck. The general advice is that you should use risk in your threat modeling, right? The process is scalable. The process is flexible, so much so that I don't accept an answer that I don't have the time to do threat modeling because even doing for an hour an analysis is worth it, and you can always return to it later if needed. I also recommend that you do threat modeling in collaboration with others. I think diverse teams of 2 to 6 people work best. There are 2 reasons for that. One is knowledge and idea sharing, which makes your threat modeling better. The other is that it will help boost the security competences of your organization. One particular thing that happens during threat modeling is that after people get a hang of it, they often like to contribute and add new stuff. For example, for you, I was mildly surprised to find out that the coordinators were not just like 2 people, but over 100, right? So that's quite a big group, and with my background in ACAM compromise, I realized, oh, okay, then we need to lock this down more heavily than we intended to. So this is a benign example, but one funny thing that sometimes happens is sometimes people, if you come in like an external party, that people like to confess. Like they see me working and thinking about threats and explaining things to them, and they're like, we actually have this word-readable file that we keep there because we never bothered to actually lock this down. Maybe it would be a good idea to revisit this. Okay. So another good reason to collaborate was to raise overall security competence. I would say it's best organizational practice. If security is something that all subunits are responsible for and have competencies to do, right? This is also a reason why I'm here today. I'm quite dissatisfied when I hear this mindset of, oh, security is hard to do, right, and important, but we don't have the competencies, so we better wait for security expert to do this, and then security expert never comes, right? I don't think so. With this presentation, I want to lower the barrier of entry and this perception of security, because I think this kind of defeatist mindset will not do to build a safer world. So I hope you find threat modeling approachable so far, and you will find it useful. Speaking of approachability, in the talk's description, I promised to tell you how fun threat modeling is. Well, I lied. So the thing is, threat modeling quickly gets repetitive. And the reason for this is similar assets have similar threat models. I guarantee you, for every threat database, the computer will say, do backups, right? If you are interpreting raw strings in your service, I'm making bets there's a privilege of escalation somewhere. but it's repetitive, but it's good. What this repetitive means is the more you do for the threat modeling, the bigger your system is, the less incremental work you need to do. Large systems do not necessarily mean that you will need to do a lot of analysis, right? So having 1 or 30 databases doesn't matter that much because the threat models will be similar for them. So this is an example of where there's a clear incentive to keep things homogeneous. Additionally, because of this, it really pays off to either choose or build secure by default platforms. Similar threats require similar mitigations. I think Google is quite good at this. Internal platform as such that it's practically impossible to send unencrypted data or store unencrypted data. If an asset has too wide permissions, say more than 10 people, you get alerts. If you try to submit code that parses untrusted strings, code review throws a warning. Okay. Also, this repetitiveness is why security guidelines work. Right? If you've never done threat modeling, but only Googled, okay, what's the security advice for X, you've probably done a reasonable job. And that's because what your system looks like is probably similar to how other systems look like. Okay. So 3 months ago, when I wrote the description for this talk, I was speaking honestly. Like I really intended to show all the fun stuff. But then I thought I would be setting wrong and dangerous expectations. Sure, there will be fun stuff with clever threads to be found. Not for you, though, that stuff is basic. But for every hour of fun, you can expect there's going to be an hour of going through a checklist. The thing is, good security requires patience and diligence, and it is work. However, it is necessary. I dare say that most security snafus are usually due to missing something basic. Case in point, you may roll your eyes at me mentioning needing to do backups, right? But after the threat model we did for United for Ukraine, we concluded that having backups is one of the critical mitigations that we want to have. So it was one of the things we checked. And we are surprised to find that Zendesk doesn't have an offering that allows you to backup and restore your data, right? It would have been quite disastrous to find that out when a threat actually hits. So luckily for us, there was an easy turnkey solution that we could buy and use. And this is all I wanted to share about threat modeling. The only question remaining is, were we secure? And I'd say, good enough to sleep well. Thank you. All right, so let me go to Slido. Is a threat model something that should be kept public or secured and hidden? Does it make it easier for an attacker to create threat if they know the model? I would say it's usually you actually want to keep it secure, right? So if you, for example, because you see what I did in the middle where I said, okay, we are going to ignore this threat. If you publish that, you're essentially telling a potential adversary, attack here, right? So there's a target on your back. That said, so if there's if you have a service that so this is a threat model about some like if you have a service, right, with an implementation hidden behind, but if you publish a framework, right, or a platform like that someone can reuse, then actually publishing a threat model of your platform that people can reuse allows them to better reason out what the security properties of the platform is. Sorry, did I make myself clear? Right? Like basically, it can be an asset for people that want to reuse your code to know what are the possible dangers for them to reuse this, right? But if this is not a thing where people are reusing code, then probably you want to keep it hidden so that people don't know which places you have weaker security in. What number of individual threats would you identify and analyze for a project like United for Ukraine? So within the context, under the constraint that we ignored the web stack mostly, right? Apart from going through a checklist of things like enable 2FA on the various platforms, the number was around 30, right? Like something like this, with most of them being benign. Like there were only a few, like the most important threat categories you kind of saw in this presentation. Well, I think that's it. Thank you very much.